My name is Karan Gaikwad. Welcome to the Week 10 project for Advanced Structural Mechanics. The topic for this week's project is computing the total strain energy on the composite body. So for the displacement field, I have defined a linear displacement field, which is a function of Z3. So it is Z3 minus Z3 and 0.3 Z3 by H. I have added the 0.3 term in the third component here because without the 0.3 term, the displacement field was looking a bit unrealistic. So for computing the displacement gradient, I've simply taken the derivatives of the displacement field with respect to Z1, Z2, and Z3 and come up with this tensor right here. And for computing the strain tensor, which is basically the summation of this displacement gradient plus its transpose divided by half. So here is the linear stress tensor that I've obtained. And for computing the Cauchy stress tensor, I've chosen this formula and taken C upon 1 plus mu outside, and then computed the trace of this strain tensor, which comes out to be 0.3 by H, and multiplied it with the identity matrix, and similarly added it with the strain tensor to which basically gives me the Cauchy stress tensor field obtained in here. So for coming to the material properties, the Young's modulus that I've taken for this project is right here, and similarly the Poisson's ratio is taken as 0.3. And for the strain energy density, I have taken the double dot product of the strain tensor and the Cauchy stress tensor, which was shown in the previous slides, which is both of them. For computing the double dot product, the method that I've used is taken the transpose of the linear strain tensor and multiplied it with the stress tensor, and then basically taken the trace of the obtained matrix, which comes out to be this expression right here in the bracket. And this we have obtained the scalar strain energy density, which is the energy stored per unit volume. So I've simply inputted all the values that I've assumed for the material here and come out with this values. And then the total strain energy for this is basically obtained by integrating this function with respect to the volume Jacobian for the cylinder in the middle here, which is R. And then the value that I've obtained comes out to be this. Coming to the MATLAB output, the MATLAB output from gives the same value that I have obtained from the manual verification right here. So this is the verification part. Coming to the MATLAB code, here is my MATLAB code. So as you can see, this is the displacement field that I have obtained, and this is the total strain energy, and the strain energy that I've verified for the second body part is right here. So yeah, that is it for this video. Thank you so much for watching. Have a good one.